Okay, Marianne, thank you very much for inviting me here. It's a pleasure to be here at this beautiful location. I'm going to tell you something about technology we developed and are developing at IHE-Delft. First, a few slides about IHE. We're the Institute for Water Education in the Netherlands. And with a mission is to educate and train professionals in the field of water and to build capacity in the sector. And our focus is people from developing countries and countries in transition. We have 4 master programs, all dealing with water. One of them is urban water and sanitation. And we're currently developing a new master program on sanitation, non-sewered sanitation, with the help or the funds of Bill and Melinda Gates Foundation. And the first run will be in April 2018. So we have a lot of alumni in the world. So when I go to projects in the world, it's always very nice that you meet the alumni from our organization, because we have been training professionals since 1957. We also have a large research community at IHE. We have now 136 PhD fellows. They're all doing research related to water. The topic of this morning is a mobile approach for fecal and septic sludge treatment, reuse and disposal. And we use microwave irradiation. And it's in the context of wash for urban settings and improving wash for urban settings under stress of migrants. So my name is Tineke Hooijmans, and I'm an engineer, sanitary engineer. This program is funded also by the Dutch Ministry of Foreign Affairs. Here you can see an overview of the partners. The project is, we work together with Jordan and the German Jordanian University, the Netherlands Red Cross, and you see here 2 of our PhD students, Peter Mario, who more or less finished his PhD research and is followed up by Eva Kokbeck. So, as I told you, the context is emergency sanitation, because especially under emergencies, when you have a high accumulation of people, high influx of refugees, we have a lot of fecal or septic sludge produced. Those tanks or pit latrines need to be emptied frequently, and you have then to deal with that material. When you don't treat it and dispose it, like happened in Haiti, after the earthquake, you get problems, a lot of health issues. So you definitely want to prevent that under that kind of circumstances. Because, well, we all know about the consequences. That was also shared with us this morning. And also, there are not so much technologies available to treat the fecal and septic sludge under this kind of conditions. And when you look at the Sustainable Development Goals, it's also mentioned there that we need alternative technologies to fill the gap that business as usual technologies have not been able to address. So we had a workshop, an emergency sanitation workshop at UNESCO IHE in 2012. That was with several partners, among which we had UNHCR, IFRC, the Netherlands Red Cross, Oxfam. And there it was stated that first sanitation is very crucial, also under emergencies. And also the focus was, until recently, a lot on drinking water supply and not so much on sanitation. Also see, when you look at the money available under emergencies, the focus is a lot on drinking water and not so much on sanitation. And also the organizations are struggling a lot with how to deal with sanitation under those circumstances. So it was clearly mentioned that there is a need for innovation in this area. So we started to think and discuss what to do with the fecal sludge to protect the water resources and also health. So the most important thing is the sanitization, and not so much that, okay, you can think of reuse, but the focus is a lot on sanitation, sanitization, and how can we kill or inactivate the pathogens present in the fecal sludge. We can do it by heating up, reducing the moisture content, or affecting the pH. We know there's a relationship between time and temperature. The higher the temperature, the less time you need to inactivate the pathogens. And when you think of liquid sludge, when it's more liquid, then you can transfer the heat by mixing of the material. And there is here, I met people from the Norwegian and Swedish Red Cross, and they worked on a technology in which they have like a system in which they heat up the fecal sludge. So it's connected to the toilets by conventional heat transfer. But you can't do that when you have more solid sludge. So then you need, for instance, airflow to heat up the matter. And another example is the LADEPA treatment technology developed in South Africa. But they have a great difficulty in this heating up the material because it's not so very effective using airflow. Another technology is, for instance, lime addition, but also there it needs to be liquid because you have to mix the fecal sludge. And when the pH increases, you inactivate the pathogens, but afterwards there might be regrowth of pathogens. And as was mentioned this morning, helminth eggs are especially resistant to this kind of heating and other processes. So then we came with the idea to use microwave technology. So we work together with the Dutch Red Cross because they are working on a desludging unit for septic tanks and pit latrines. And we want to treat then the material produced in a containerized system, compact and portable, that we can easily transport to location and work together with the organizations that empty the systems, and we can provide the treatment and sanitize the fecal sludge. So what is now the idea behind microwave dielectric heating? Because we call it dielectric because there are two mechanisms going on. Well, we all have a microwave at home, I think, but you don't normally think about the processes that are taking place there and how it actually works. So what you have is, when you have dipolar molecules like water, they start to oscillate on the changing electric field caused by the microwave radiation. And when you have ions, you also get an oscillation by the ions because of the changing electric field. And those two mechanisms result in heat increase of your material. And when you think of fecal sludge, it contains a high amount of dipolar molecules with water, but also organic complexes and ions. So it might be a very good candidate for this heating. And also, when you look in literature, it's being used for treating sludge generated by wastewater treatment plants on a small scale. Then when you see in literature that when you mix it with other material, like for instance char, that you can even heat it up very rapidly, the material. So what you have with microwaves is that you have like heating from inside out, and you're not heating up the walls. So it's a very efficient and rapid way of heating. Like when you have conventional heating, the heating goes from outside to the inside. You have to mix it, and it takes far longer. So when you have microwave heating, it's very rapidly compared to conventional heating. We did some testing in the laboratory, so the first PhD student, with fecal sludge. And this is an example of the kill of Ascaris eggs as function of the amount of energy we put in. So, well, the main message is that you can see here an increase in temperature, and you can see here the die-off of the Ascaris eggs. So it's a very good and efficient way of killing even those very resistant eggs. So here you can see Peter Mario. This was the lab scale system. Here you can see the sludge when it's dried up, so you can stop after sanitization, so when you kill the pathogens, but you can also continue and generate a dry material that you can also use to burn and get energy from. So it has a certain calorific value that you can reuse. What is important are, okay, what is the properties of the sludge? What kind of pathogen indicators are we using to see how effective this approach is? What is the energy consumption? Because it obviously costs a lot of energy, but we also want to be realistic and see how we can reduce the amount of energy. And can we use an alternative energy source? So when thinking of the system, so this is like the flow sheet of the whole system. We have the fecal sludge, we have to screen it, and the screen material, we can incinerate it. After the screen, we have a thickening process, and the water phase goes through an ultrafiltration and a reverse osmosis step, so we generate water of a high quality. And after thickening, microwave irradiation is used. You can stop there and use the material, for instance, in agriculture, depending on how the people perceive this, or you can, if that is not possible, you can dry it you can dry it further and incinerate it, and use the energy that is generated there back into the microwave system. So that is the conceptual idea. We work together with Jordan, the German Jordanian University. They are working on the application of renewable energy to use that for the system, and we will test the pilot system, or you'll test the system at a pilot site location, first at a university in Jordan, and then at the real site in June 2018. We work together with the water authority in Jordan to think about the standards for wastewater and sludge reuse. And also we want to include and see how the people perceive this kind of technology and if it's acceptable and working in the field. There is a water company involved, which might be a potential end user and is really interesting and see this as a good alternative technology. So these are the activities we're working on now, and we hope that, well, we have to see what our experience is on the basis of the application, but for us, so far, it seemed like a promising technology. Yeah, and that was the presentation and the idea I wanted to share with you. Thank you very much for your attention.